Fine. It's got the 3-2-1 this time. Who cares? Okay, so they're working on stuff. I just did these real quick. Notes for today. I'm okay. Positive and decreasing. So I was just discussing with those that these are positive slopes, but they're on a concave down part. So that's the interval that you have a positive decreasing. Review. And then we had to make a point that maybe the point of inflection somewhere around there we discussed, because that's where it changes concavity, which changes decreasing and increasing stuff. So negative, these slopes are negative here. I didn't really make that a good tangent line, but it's kind of like its shape. And it's on a concave down, so that's negative and also decreasing. And then from 4 to 7, they skipped positive and increasing, positive slope of all these tangent lines and on a concave up. And then 2.5 to 4. Now, while I started the video, they were trying to make their own graphs. I told them 3 was a bugger. Anyone have a guess on 3? Anyone get 3? I'm gonna go walk over by it. Okay, so is this last summer? Well, so he says on that. Okay, I guess this could be, it's just it is a 1, 2. I don't. 6, 7. No, 7. So you can't hit 7. Okay, it's 1, 2, 3, 4, 5, 6, 7 things. You know what I mean? Hey, you need one more thing. You know what? That's only the 3, 3. Those are regular zeros. Yeah. You got beautiful close. Like you just gave me a degree 3. I'll show you. You were the closest. I like your other guys. What you did. All right, so I'm going to go ahead and throw the first one, which is easy. You'll probably be fine with this. All right, had some good guesses, but then I'll tell you some of the mistakes on the third one. Degree 3, negative leading coefficient, 3 real zeros. Who cares? I think that's it, right? 3 that is negative and 3 real zeros. That could be anywhere. 3 real zeros. It has to end like this. Ain't no thing. Chicken wing, right? Can't be. There can't be. I mean, you can put the zeros anywhere. They didn't say anything about that. Polynomial has 2 points of inflection. Remember, 2 points of inflection means 3 bowls, right? Right? So 2 points of inflection. Let me make sure I had that right. One absolute maximum, and then no absolute minimum. Okay, so then I'd have to have a bowl, and then a bowl, right? Okay, so it had to be something like that. I didn't draw my x and y axis. I'm just going to not draw it at this point because it doesn't really say anything about zeros as well. 2 points of inflection, one absolute max, no absolute minimum, and I cheated and made that one a little bit higher. All right, so it has to be an x to the 4th looking graph facing down for that to be occurring. Now, here's what we had for some people doing odd. Awesome. You hit the odd, but 2 mistakes that I saw. People had a degree 7. So I want to kind of share their answer. Was it something, did you have it as a negative too, like a ending negative? Yeah. So you went, I think you went like this, had a roller coaster like this. Is this right so far? And then did you go through yet? Or did you go through, I forget, you went through now? You went through now, then hit here, right? And then you did this. So odd would mean you have to have a reflection of this on the other side through the origin. So this would have to be down here, right? I feel like I'm screwing up. It's kind of hard to do. And then one more turn out there, right? It's something like that. Really hard to do odd. And what I'm trying to get in my head is, I do have that reflection over here. Here's the problem with that answer. This is a degree 7 because it has 7 directions. 1, 2, 3, 4, 5, 6, 7. So good idea. Probably take like a half point off on missing that. Really, the only way I can think that this would happen is you have 3 zeros only, they said, right? Didn't we only have 3 zeros there too? All right. Is the 0 that goes through the origin is multiplicity 3. All right. So that counts for 3 of the zeros. All right. And then does it say it's negative? Fifth degree polynomial with a leading coefficient that is negative. So then here's a fourth. And then here's a fifth. And that should be, I'm trying to make it odd. Yeah. Then this point, close enough. I wouldn't be like a real jerk on your measurements here. But that is a degree 5 because 1, 2, 3, 4, 5. All right, the multiplicities count that third, fourth, and fifth zero there. Anyone do that I didn't get a chance to look at? Did anyone make that adjustment after I told you you were? Yeah, you actually said it. You did actually say it. All right, so good. All right, polynomial with approximate inflection points at -1 and 2 and the following limit behaviors. All right, well, let me get that written down. That shouldn't sound too bad. We're at -1 and 2. So I have to have bold changes there. And both limits end up and up. It's almost like this one again, but flipped, right? Because if I have a point of inflection here and a point of inflection here, it doesn't have to be in the same spot. Then I have to end up, then I have to be going down concavity wise, and then it'd have to be concave up. That's what points of inflection means, changes in concavity. Okay, so good little reviews there. Good, I love this. I love being an algebra teacher. I love factoring. I don't know why. All right, but for each polynomial, complete factor each one, state the real zeros and their multiplicity, x-intercepts, identify the y-intercept, and behavior, graph without a graph or extreme need. This is important. This is a sketch. So the most important thing is I don't care how high and low you go. Without a calculator, you really cannot find maximums and minimums and what the coordinates are without calculus. So you'd have to use either the calculator, there's a max or min, the max and min on a calculator, find the maxes and mins. You ever see that? Let's open that up real quick. Not that we want to do that right now, but we'll hit the trace feature. Wrong. I'll hit the second trace, which is calculate. I thought I hit that. And then there's where your max and min features are on your calculator. But this is not the point. We just want to have a sketch with the zeros, what the end behavior is supposed to look like because of the leading coefficients and the degree, and then put it all together and not care how high and low it goes. A lot of times these go really high and really low. You got to do some zooming to find the whole nature of the graph and see all those things. We'll probably get to that later. It's just not for today. All right, so let's speed this up. Here we go. Good factors. Anyone? Good FOILers. But what's the first thing you always look for in factoring? Hurry up. GCF. I guess I'll take out a 1 or an x and just leave this as 1 minus x squared. And then did you know that is a difference of 2 squares? One thing I have not done with the regulars is we did some factoring solving today. I forgot to do a difference of 2 squares example. And they'll need it, I'm sure. Get that practice. All right, so move that over there. Yeehaw and all that other stuff. Okay, wrong. You should have been saying something, right? Right. Okay, sorry, I wasn't finished. I always say that as an excuse. All right, so my x-intercepts are 0. Let's spread this out. 1 and -1. Reverse respectively. I wrote those in the opposite of the way I just said it. Next thing is this is a negative cubic, so the expectation is it goes like this, right? So it's got to fit these. This is like the first one that was easy. You have 3 zeros, negative leading coefficient. The graph would have to look like this. Couldn't care less how high or low you make those loops. It's not the point. Okay, and there is a calculus thing that allows us to find those. You will learn maybe that next year, how you can do it by hand, finding out what these points are. But anyway, we're done there. So, what's the y-intercept? What is the y-intercept? So the x-intercepts are, 1, 0, 0, 0. What's the y-intercept then, everyone? 0, 0. Okay, that's why I paused there for a second. X-intercept and Y-intercept at the same time. All right, so X, I just wrote the intercepts. I don't want to label them there. Then end behavior with limit statements. These get a little old. I think for no purposes, I'm only going to do a couple of these and verbalize the other ones. Because I think you get it at this point. Would that be true? You get it? You get the point? We don't have to keep... it's refreshing dealing with you guys. Sorry, don't tell your friends that are in AB, but we can get something, lock it in, and move on. All right? We don't have to dwell. And then, did I do that right? Yes. Infinity goes to negative infinity, and then vice versa. They're flip-flopped. Okay. Love factoring. All right. And then graph without extreme and not need not position. So we did everything we needed to do there. Okay? Got it? All right. Next thing. What kind of factoring is this? Starts with the G. Grouping. Now, you got to make this plus a negative. All right? And then you put the parentheses around. You don't make that plus negative. It's actually technically wrong, and then it may screw up your factoring. I think I got some space up here, so I'm going to go up here. Pull out a 2x squared, and then you're left with x plus 5. Yell if I'm doing something wrong. I don't know. My brain is still scrambled. Is that wrong?
2x.
What I?
2x.
2x. Oh, wait, what?
2x.
Oh, yeah, 2x. Good foiler, say it. I didn't check. I'm a bum. I'm a charlatan. I'm a fraud. All right. That does end up becoming 4x cubed. Good. And then 10x squared. And then I can take out a negative 2. That's interesting. Right. And then that's 2x plus 5. The only way that works, or the only way grouping is going to work, is if these are equal, and they are. Okay. So if they're not equal, you either did something wrong or it just doesn't factor by grouping. All right. It's one or the other. All right, and then 2x squared minus 2, we set that equal to 0. Well, okay, let's not go too fast, even though I think we've done enough factoring to say you should know what you're doing there. And then to find zeros, we plug in 0 for y and then solve for these x's. All right, add 2, then divide by 2. That becomes x squared equals 1. And then square root. What do I got to do when I do that? What do I got to do with that 1? Plus, anyone? Plus, minus. So my x-intercepts, can I not list them? Is that okay? Is that all right? Okay, so I can write them though. But that's the key though. I guess I will write this though. Or you could have factored this further. I could have taken out I should have done it. I should have taken a GCF out in the first place. But it really doesn't matter for finding the intercepts. And then this would have been x squared minus 1, which is x minus 1, x plus 1. Another proof, though, that's why it's plus minus if you choose the square rooting method. If I factor, I would get x minus 1, x plus 1. Okay, over explanation. Negative 5.5 is negative 2.5, right? Negative 5 halves, is negative 2.5, correct? All right, and then what's the y-intercept? That's actually staring you in the face. What's the y-intercept? What's the y-intercept? Look at that one. 0, comma, negative 10. So that is important. My bad, dog. That is important so you know the shape of this graph here. All right, so it is a cubic, so it does go like this. So does all this fit? It most certainly does. Maybe a little bit high. All right, and then that might be the extreme. I don't know. Seeing that these are symmetric here, it might be the extreme of value as well. I'm going to make a guess that it is and make it the extreme, but doesn't matter. It's not what you have to do. I'm just making a point there. All right, so the y-intercept is 0, negative 10. That just comes from plugging that in. I like this stuff. It's fun always doing algebra and stuff. I find it easy and actually weirdly relaxing. I don't know. I'm strange that way. Okay, then moving on, now we can start talking about now we got some multiplicities. So yes, I finally will do the right thing and take out a GCF first, because it is imperative that I do. And then this is x. I could probably have you do these, but let's just get it done, right? Is that all right? And then hopefully I can leave you alone one day and just let you work on something. I feel like there's been too much yip-yapping by me. And then what multiplies a negative 2 and adds to 1? What are the answers? And it's actually Yes, it is +2. I almost said -2 and +1. Yeah, and I got it reversed. So it's x. But a good foiler, say it. Might have caught myself before you caught my mistake, because I usually do make sure real quick. Right, 2x and -1x is 1x, and then x squared and -2. I'm all good. Okay, so here's the thing, though. Let's list this one. Everyone forgets this one. That's 0, 0 with multiplicity 2. So I will list that one and not be lazy, just to make sure you remember that. So the expectation of that picture. And then just -2, 0. I almost never care about multiplicity ones like you writing it. I only write when multiplicities are 2 or higher, but whatever. Okay, so 0, 0, and then -2, 0. Yeah, I don't think we quite did this last year too much, because we really focused on the just x cubes. So we may have done this like in one day with zero analysis, making a sketch. I remember the picture on the test. They're in that cabinet over there. But yeah, I think you did it just one time. All right, then x to the fourth should be like this. My n should be like that. So how does that all shape up here then? Through this last zero, it's got to go straight through, normal zero, and end up there. So I always start on the right or the left, but left seems smart. And then this is a double zero or a multiplicity 2. Sometimes I do call them doubles. So that's the bouncer, and then this flips around and then goes up. Should make that a little bit more coming out, but that's all right. That works. Easy? Very easy. Okay, then I'll explain what I was talking about that book online that I don't have yet, but there's a PDF on your calendar that you can just open up. I don't even think we did that much last year. We didn't. Maybe in the beginning of the year we had a fake book that we had to use. Okay, same thing. 15, 80, and 80. What goes in all three of those? Is it just 5? Yeah, 15 doesn't. So 5, not 3. So 5. And then it's x cubed. Now we got a triple. We got a triple 0. And then this is 5x squared. Again, I could probably have you do these and you'd be fine. How many times 5 going to 80? Am I wrong? Did I use it wrong?
Yes.
3. Oh my gosh. I'm just seeing if you're paying attention. 16? Oh man, I can't believe I knew that. 16x and then 16. The old man's struggling. His old brain is deteriorating. Hold on. Okay, so it's got to be 3x and 1x, right? And then could it be 4 and 4? No, 12 and it is. Okay, already is. So good. You guys are beep up and your brain's calculating and thinking about. And again, this is easy. So start with the easy one. This has to be the case. Now, how do I get 16 in the middle? All right. Oh, I gotta scare someone. Anyway, and it is 4 and 4 because I could imagine 4 times 3 is 12, and then 12 plus 4 is 16. Let's see if it worked. All right. Anyway, all right, and then it's plus plus. Someone's got the hiccups, so and I feel like it's my role as teacher to solve. Okay. Anyway, so x plus 4. That's -4. 1, 2, 3, 4. Are you okay? Did I scare you too, or no? That's for your future hiccups. All right, and then -4/3, right? -4/3. Okay, so that's -1 1/3. All right, x to the 5th should have this. All right, but we don't know all those terms. So through the last 0, it goes down forever. Wait, that's not the. Nope. Okay, good. And then goes up and then hits this 0. This is going to be tough. Okay, so I'm going to zoom in on this. This is how I always approach this. I want to come down here and then start getting close here. And then flatten out and then do it like that. Isn't that a good way to do it, right? So start coming to the 0 farther away from it and then slant it through. And then that's how you show multiplicity 3. Okay, and that's the best way I think you can do that. Doing all right? Great stuff. You can list all the stuff. Y-intercept. What is the y-intercept? It's easy. If I have 0, 0, that's the y-intercept, right? That's x-intercept and y-intercept at the same time. All right, this is some more algebra that gets a little bit more. Well, I like it. Okay, so now what is this equation that would match this? Well, we know we should get an x to the what? X to the what at least? 4, right? Right? You guys said 4. And it says, why does it say least possible degree? Because it could be 6, 8, 10, and I don't see all the other attributes. Like up here, this could like have another wrinkle that I don't see off the screen, and that would create a couple other degrees. So that's why we say least possible degree. Well, minimum, that's an x to the 4th, and I can see these zeros. So here's what I got to do. I got to put this general form here, f of x equals, I don't know what the leading coefficient is. Okay, so that's what we have to do first. Children, people poking over there like they're in grade school. Pokey pokey. All right, and then this is x. What is that? X minus 1 or x plus 1? Minus or plus 1? Too late. It's plus 1, right? Taking too long. Okay, but wait a minute. Is that a normal zero? Yes or no? Is that a normal zero? Yes or no? Yes. Okay, kind of put this out of order. That one's at, if you wanted to say x minus 0, that's fine. But what's the multiplicity on that? 2 or, anyone? 2 or, 4 or, 6 or, 8. Let's just do 2. Least possible degree, right? It's another reason why least possible degree. So, yeah, but if it was more than that, actually really tight there, what would happen is this loop would be lower and this would be flatter there, even though these are really close. Who cares? Nobody cares. And then 1, 2, 3. So that's x minus 3, right? Do I have everything? But wait a minute. How do I find that a? Now, your teacher was nice. But I do see some other points I could have pulled, like that one, right? Doesn't that look perfect? This is another arbitrary point. What is a coordinate? Blank, comma, blank. Tell me. Blank, comma, blank. What are the 2 letters? No, they're up there. X, comma, Y, right? So now I can plug that point in or that point. They were nice and showed you this. You'd have to pick one that looks like it's spot on a nice, perfect coordinate. So I could have plugged in 1 comma negative 2, or let's choose the one that the teacher noted nicely. So now what I'm going to do is plug in negative 2 wherever there's an arbitrary x, and 8 where there is a y. Okay, and that is y. And then what is left over is a. I don't think you've ever done this before, but I mean, you actually did this with finding equations of parabolas. I could pull that test out and show you that you did that last year. And it was just either vertex form or intercept form. So it's very close to the same concept. Children, do I have to separate you two? Okay. All right. So much fun. Teaching in America. I forgot about that line. Teaching in America. Okay, and then 8 equals a, and then let's get these. Is this negative 1, right? And then this is 4, right? And then this is negative 5, right? Yuggly. Okay, so then this is negative, is this 20? So a equals, so 8/20ths, which is, I don't want to make this mistake again. 4 goes in 8 twice, 4 goes into 25. Right? By the way, what if you got a negative there? Would that make sense? You made a mistake, right? So you better get a positive, and it should be. Now, how do I know if it's 2/5 is right? You really don't. You just got to trust yourself. Does it say if it says standard form, I'm going to puke. Come on. These sadistic teachers that I teach with, they're so mean. Because what does standard form mean? You got what are good factors? Foilers. You got a foil. That actually ain't no thing. Chicken wing. Right? Okay, just wondering. So foil first. Your hiccups are gone, aren't they? You're welcome. All right, 2/5. And then this, you know what? I'm gonna be like super foiler. So this is x squared, but then times x squared, x to the 4th. No, you know what? Slow down, Sparky. I'll do the next one. So x squared, negative 3x and 1x is negative 2x, and then negative 3. And then I could distribute the whole thing because I do anyway. 2/5 x to the 4th, Ooh, watch with my fraction abilities. This drives me nuts when AB students think this is like calculus, what I just did next. 2/5 times -2. -2 times 2 is all that happens. That becomes -4 x fifths, x to the third. So you just multiply the numerators. -3 times 2 is -6. So -6 fifths x squared. It's like, you got over there? Snappy, snappy. Snappy, snappy. Pokey, pokey. You got a lot going on over there. Everyone all right? What time is it? I love this lesson. I like algebra stuff. Okay, then the last one, find a pound only given point, leave in intercept form, thank the maker. All right, if there is one. Okay, all right, so zeros are 0. So here we go. We got the old f of x equals a, same idea. I don't know what the a value is. That's why there's another arbitrary point given. Okay, so a 0 is a 0. 0 is a 0. If you really wanted to and say x minus 0, just to exercise the idea, it's always x minus whatever the x-intercept is, but it really is just x. -1 multiplicity 2, so that's x plus 1, right? And then it's squared. And then 3 multiplicity 2, that's x minus 3 squared multiplicity 2. All right, and then it's degree 5. Wouldn't you agree that this makes a degree 5? Right? Okay, so we're good. Remember it said, now leave this in intercept form. Okay, and then it's the same thing. You barely probably need me to do this. 1 gets plugged in for the x's. This is the way you get the a value, the stretch shrink factor. Like how we really get the shape of the graph. And then that's 48 negative. So you plug in -48 here. I find I'll finish it for the movie purposes. Then 1 minus 0 is just 1. 1 plus 1 squared is 1. And then 1 minus 3 is -2 squared, which is 4. Can I do that? Was that too fast? Wait, did I do something wrong? What did I do again? Oh, 2 squared is 4. Again, I was seeing if you're paying attention. Is that good now? Wait, is it? I don't know. And then the last one, 1 minus 3 is -2, and then you square. Hi, caramba. Rough day, rough week. Rough. And then divide by 16. Oh, isn't that nice? Isn't that 3 negative? Who is this guy that can't do simple tasks? And then luckily it says leave in intercept form. Thank you. Kids also have to finish my sentences for me. Let's end this. Maybe. All right, there you go.